Okay, so we're looking at your questions, and remember, you guys, that the question was, what do you know about the Pythagorean theorem and what does it measure? Obviously, I'm asking this question because our first week starts us off with using that, and sometimes students don't remember it and they get a little bit confused. So I just wanted to talk about it. So Danny said that the Pythagorean theorem was one of the earliest theorems known to civilizations. It was a very old theorem, that's true. It's for the Greek mathematician and philosopher Pythagoras. You are exactly right. And you've got the formula. I'm assuming that you mean those are squared, like a squared plus b squared equals c squared. And you say it only applies to 90-degree triangles. That, again, is another very important part. Identify the legs and the hypotenuse, substitute values, solve for the unknown. Okay, so what I'm reading into that, Danny, is that you are using it to find the lengths of the legs and the hypotenuse. So very good. Monique, you remembered the formula, and that's good. So you learned some of it in 8th grade. Awesome. The only thing is you didn't put what it measured. So we're going to talk about that. And the Pythagorean theorem is the measurement of angles in a triangle. So Cece, it's not actually the measurement of angles, so that's good you brought that up. It's actually going to be the measurement of the side lengths. And so we'll definitely look at that. Demetrius, it is a right-angled triangle, and the square is equal to the sum of okay, good. So you know the formula, but again, what does it measure? Dustin, what does it measure? And Israel is an ancient Greek theory, true. So what is the theory and what does it measure? So that's a little more detail that I would like to see. Make sure you guys try to answer the questions completely and in their entirety. All right, so let's actually look at that, you guys. Let's go forward here and look at what we're going to do. So we're going to explore the distance formula, and the distance formula is directly related to Pythagorean theorem. So by knowing Pythagorean theorem, you will know the distance formula. And that's the cool thing about the Pythagorean theorem, is that it's actually now used for lots of different things, including finding circles in the coordinate plane as well. Okay, we're going to find the distance of line segments in the coordinate plane, and that relates to the distance formula, which relates to Pythagorean theorem. All right, you guys, so quick heart to heart here. This is your first week. Everybody has an A this week, right? If you don't work, then your A drops. Think about this. You only have 3 assignments this week. You guys should be done with assignment 1 today, right? It's due today. So everybody should do the very first assignment today. It's not too bad. It doesn't take too long. Watch the quick lesson, do the assignment. Everybody give me a hand raising if they understand that expectation. Raise your hand. Raise your hand, you guys. Awesome. Awesome. Very good. Good job. Okay, good. All right. So just make sure you keep up, because if you get to like week 5 or week 6 and you think, oh, I have time, you don't really, because to be successful in math, right, you have to be proficient each week. You can't just get to the end and do one assignment and be like, I'm proficient, because every week there's new material. But the material all relates to each other. So it doesn't necessarily get harder. We just keep adding on to what you know. So keep up, you guys. Keep up. You have to demonstrate that proficiency every week. And I know that you guys are all totally capable and you can do it, and you'll be very proud of yourselves when you get to the end of the quarter and summer starts and you've earned your credit. And you won't be stressed at the end of the quarter because you won't be behind, you'll be caught up. The other thing to think about this quarter is there is only 8 weeks, so you only have 8 weeks of work to do, so it's a little bit shorter. Okay. So I don't know why this says week 8, maybe. Maybe that's what I was thinking. This is week 1. All right, you guys. So in your note pods, or not yet, not yet. Hold off on the note pods, you guys. Sorry. Okay, overview of what you guys talked about. So here is the Pythagorean theorem. A few of you guys said it has to be a right-angled triangle, and that's true. This theorem does not work unless we are using a right triangle. And many of you guys said a squared plus b squared equals c squared. In different ways you said that. The key thing is that the hypotenuse is always your c, right? It always has to be the longest leg. So what I've done here, because this goes along with what you're learning this week, is I've drawn 2 lines, And if you picture that, these lines are eventually going to be in a coordinate plane. Okay, but if they're in the coordinate plane, they're going to be difficult to find their length. So just know that anytime you have two lines, you can do something like this. You can, let me pick a color you can see, you can always make a right triangle. You can come down, you can come over, and you can make a right triangle, and you can make that be a hypotenuse. I can do it below, I could even do it above if I wanted to. Okay, and then that way you could find this unknown variable x. So just something to think about what we're going to be doing with the distance formula at the end of this week. So now, you guys, in your note pods, what I want you to do is, any way you can, tell me what the length or the distance of this segment is. So you guys type it in your note pod. How long is that segment? And I can make it, if you need to make it bigger, you guys can click on the full screen. I can also do that to help you guys a little bit too. Okay, so go ahead and make your guesses. How long is it? Like, is it 5 units, 6 units, 4.3 units? Like, how long is it? So it's a good question. So for example, Danny, if I had, and you may already have understood based on what I was saying, but let's just say I had a line like this, you would know how long that line is because you could just count that it's 1, 2, 3, 4 units long. So we're just finding the distance of the line or how long it is. Okay. Okay, so do you guess? So you guys, so what I'm doing now is figuring out what strategies you use to figure out the length. So Monique made a triangle and counted along the x-axis of the triangle. Okay. So whenever you're solving math problems, what you want to come up with first is a strategy that you're going to use to solve this problem. Guessing is definitely a strategy, but we're going to try to work beyond guessing and try to use things we know. So we just looked at triangles, we just looked at Pythagorean theorem. Okay, so a lot of you guys counted. Okay, if we do that, and I'm going to see if this will work. Never mind. So if I'm counting though, you guys, I know that some of you guys were counting like this, along the lines 1, 2, 3, 4, 5, 6. You were doing that, right? Well, think about this. And let's move this up a little. Think about this little 4 guy, right? If I do this and this, first of all, so Monique, this is kind of addressing you, and I just want to make sure, is this what you did? Did you go 1, 2, 3, 4, and so then you said that was 4? Okay. Well, can you see that this distance is shorter than this distance? Okay. Picture like this is your house, right? So here's your house, and this is school, and this is your friend's house. If you were going to go to school and you traveled to your friends first and then to school, that would definitely be a longer distance than just taking this hypotenuse route this way, right? So you can't just count the x. And then I think some of you guys did something like this where you were like 1, 2, 3, 4, or you counted like that. But remember that if you go from here to here, that's not going to be a 1, right? 1 goes from here to here, and we just said that this distance is going to be shorter than the diagonal. So you really can't just count, okay? Because that won't get you the right answer. Because when you go diagonal on these squares, that's going to be really different than just counting them evenly. So remember what we talked about, you guys. We talked about using Pythagorean theorem. So I like, Monique, that you actually made a triangle. Very good. So remember I told you guys you can make a right triangle, and then from your past, I know it's probably back in 8th grade, like some of you guys said, if you make a right triangle right here, you can use that to help you solve the distance here, because this is really just your C. Yes, yes. Okay, And then these legs are A and B. It doesn't matter if you call the base A or this vertical one A, but either way, those are A and B. Well, you guys can count the legs down here, and you can count these because those run along the squares evenly. So I could actually count this. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I can count this leg as 12. I can count up, so I can go 1, 2, 3, 4, and I can count that leg as 4. So if I do that, could I not use the Pythagorean theorem to find C? Yes, I could. So that's what I'm going to do, you guys. So if I plug this in, I have 12 squared plus 4 squared equals C squared. Okay, so if I do that, then I can find this distance C. Now we talk about the distance formula. If I take and solve for C, I'd have to take the square root of this, right? Which means I'd have to take the square root of everything here. So I could rewrite this equation as C equals the square root of 12 squared plus 4 squared to solve it, basically. Okay, and if I simplify that, I get the square root of 144 plus 16, or the square root of, if I add all this together, 160. And if I do that in my calculator, take the square root of 160, I get 12.6. So, some of you guys guessed 12 and some of you guys guessed 13. You had a really good educated guess, but it wasn't precise. So the only way to really calculate this is to use Pythagorean theorem. And we were talking about the distance formula in the beginning. This is really the start of the distance formula. Okay, so before we get into that, I want you guys now, first of all, do you have any questions on how to use the Pythagorean theorem, how to find the lengths of the base and the height, how to make a right triangle? Okay, good, Danny, good, because we are going to do it. All right, so then let's try it, you guys. So I don't see any questions. Danny wants to try another one. I'm going to have you guys do this one. So I'm going to make it bigger. So this time in your notepads, I don't just want a guess, right? I want you to actually use that strategy and see if you can find the length of this segment. Okay, so go ahead and do your work in your notepad as well, and then I can just follow you guys as you go. And we'll try this, and then we'll conclude with tying it all into the distance formula. So Danny needs help, so let's do this. Cece, why don't you tell Danny where to start? What should be the first thing she should do? Okay, good. So Danny, maybe make a triangle. And I know this isn't on your paper. Oh, you got that far? Okay, good. Very good. I know it's not on your paper, but what you guys could do is you could do a rough sketch on your of a triangle on your paper. But let me ask Monique then, what is the purpose in making a triangle? Like what's going to be your next step after you make a triangle? What are you trying to find by making a triangle? Give me one thing you're trying to find. Monique, what do you want to find when you make a triangle? Oh, okay, good. Good. So when you make a triangle, you're going to try to find what a squared is. Okay, so first you have to find a, right? And then you can square it. So good. So D, give me another thing then that you would find by making a triangle. So Monique got the A. You're trying to find A. D, what else would you find when you make a triangle? What else are you trying to find? Okay, you know. So D, here's what I'm going to do, right? Look back at this triangle. When I made the triangle, what are the two things I found? So I found A, which was 12. What else did I find? Okay, so you know. So good. I need to find A and B. So you guys do that as your first step. So Cece said make a triangle. Monique said find A. D said find B. So why don't you guys write that in your notepad first of all. What's A and B? Go ahead. All right, well, let's see. It looks like you guys got A and B, but no one really started it except for Danny and Cece, it looks like. So you guys, one of the things that's, like I said about this webinar, is this is your opportunity to try and to fail, because only by failing can you learn. If you don't do anything, you'll never learn. So if you always just wait until somebody else does it, or you don't even try, you know what, it'll be hard to develop strategies and it'll be hard to get better in math. So always, you guys, during these webinars, I want you to try, not just sit and wait, because otherwise the webinar can be kind of boring for you. Okay, so we talked about making a triangle. So I want you guys to work on that each webinar, okay? Would you guys participate? So we talked about making a triangle, a right triangle. That's the only way we can use Pythagorean theorem. And Pythagorean theorem is the only way we can find C, this distance, because it's not a horizontal line and it's not a vertical line. So you guys, depending upon which one you said was A and which one you said was B, because it doesn't matter, I'm gonna call this one B this time, just to be different. So the distance is 1, 2, 3, 4, 5, 6 squares. So one of them is 6. And if I called this one A, 1, 2, 3, 4, 5, 6 squares on that one too. So again, kind of hard to measure from your computer maybe looking at it, but they should have been 6 and 6. So some of you guys got 6 and 7, probably just kind of a counting error, and that's okay. So now that we have 6 and 6, and if I look at what you guys did, so Cece squared each of these and Danny squared each of these. And that's exactly what you want to do, but now we have 6 squared plus 6 squared, and that will help us to find C squared. So I'm going to solve this normally first, and then we'll tie it into the distance formula. Well, 6 times 6 is 36. So when you guys put, like Danny, you did 7 squared, 7 times 7 is 49, that's true. So you guys had part of the answer, but I'll show you, Cece and Danny, what the extra part that you needed to do. So you guys did this, and then you squared the second term. Very good, right? Then you added these together, and you got, you didn't quite get 72 because you didn't use 6 and 6, but you added those together. Okay, but you guys, let me ask you guys, and everybody answer. Am I done? Is my answer 72? Okay, good. Very good. So Monique, right on. Danny, good. Cece, you're right. No, you are not done. Exactly. So in order to solve, you have to take the square root. That's the only way to undo a square. So when you undo that square, now you're left with C, and then you just have to take the square root of 72, which is 8. I'm going to round to 8.5. So 8.5. So C is 8.5. Okay, so I'm using the Pythagorean theorem. So Cece, you really just have to be, yeah, exactly. When I'm counting, yeah, just be careful. And it'll be easier, when it's more in front of you and not so much on a webinar. And then you can actually physically count it. Okay, so, all right, you guys. So before we check out, what I want to do is, hang on, where is it? I'm going to open a new page here, because all this is stuff that you have already done. So there's new learning in this week, right? You can always go back to Pythagorean theorem if you get confused. That's a tool that you have, right? That's a strategy. But what I want to show you guys is how the distance formula, and we started to look at it, but I want to show you how the distance formula comes from that. So if I have my line, And I'm just going to put it here, let's just say. And then I write in my coordinates, okay, because all this assumes that you're on a coordinate plane. So -6, 4 for this coordinate. And this one is at 2, 7. Okay. If I were to draw in my triangle like this, what we've been doing so far is we've just been counting, okay? But the other thing you can do, other than just counting, and this coordinate here of my right triangle is, what is that, 2, 4? 2, 4. So let's just say that I counted. I would get 1, 2, 3, 4, 5, 6, 7, 8, right? What I want you guys to think about is instead of counting, this is my x distance. So instead of counting, I can use the -6 and the 2 to help me find that distance. So what I can do is I can say, well, I could do -6 minus 2, and that would equal -8. Because remember that if you have a minus, you can turn it into a plus and make that be a minus, okay? Then if I want to find the other distance, and let's highlight. So I've got 4 and 7 that I'm going to be looking at. This distance is 1, 2, 3. But how could I use 7 and 4? I could do the same thing. I could do 7 minus 4, and I can get 3. Some of you guys are saying, yeah, but that's negative when it should be positive. But think about the Pythagorean theorem. It's a squared plus b squared. So the -8, when you square it, will turn positive anyway. Okay? So try to follow me here, you guys. La, 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 la. If I'm using the distance formula, okay, and this is where it comes from, it's basically, remember, c squared equals a squared plus b squared. But instead of c, I'm going to put d because I'm finding distance. And instead of squared, I'm going to square root all this to undo that square. Couple more substitutions. To find a, which is 8, all I have to do is take my x coordinates and subtract them. So I can take my x2 minus x1, subtract them and square them. So that's my a squared. To find b, all I have to do is take my y coordinates and subtract them. So I can do y2 minus y1 and square it. That looks really complicated, but if you guys just keep in your head that this is actually just a squared plus b squared equals c squared, it's just rewritten. And this is called the distance formula, and it's just an easy way to find the length of a line segment if you know the coordinates at each endpoint. Okay, so when you guys are working on this, feel free to use the distance formula. It's easy just to plug in coordinates, or feel free to make a triangle and actually go back one step and use Pythagorean theorem. It actually doesn't matter. You will get the same answer because the distance formula is derived from Pythagorean theorem. All right, you guys, questions on the distance formula on Pythagorean theorem on finding the length or the distance of a line segment? Not for now? Okay. Good, Danny. Okay, everybody raise your hand if you're in good shape, or type no is fine too. So CCD, you're good. D, you raise your hand, Israel, good. Monique, how about you? Okay. All right, you guys, then if you're good, so where you posted in Schoology, I want you to go back. This is post number 2. Now that you know what Pythagorean theorem is and what it measures, I want you to post, how is the Pythagorean theorem related to the distance formula? That's what we just were talking about. So put that in there, and then make sure that you respond to 2 other people's posts. That's the only way to get a proficient, right? So put in your response and then just make a comment, respond to two other people's posts. What I'll do too is I'll put these post questions in there so that they're in there too as soon as we're finished. All right, you guys. Hopefully you're in a good start for this last quarter. Make sure to get your assignment done today. Get your assignment done. And I will see, probably Monique, I'll probably see you tomorrow. Maybe Danny. Maybe Cece, although I won't be at Central. All right, you guys. Oh, you'll be there. Awesome. Very excellent. Okay, I guess that's it then, you guys. I will see you all later. Thank you.